All right. So we're going to be on 10.4 today, which is about inequalities. All right, and we mentioned this a little bit, like right before our exam. But again, just here's the little summary of what each of those symbols means and how to read them. Okay, so we kind of went over that before. So now we're going to talk about how to plot that on a number line and also how to write it using interval notation. Okay, so when we want to plot our inequality on a number line, the first thing I would do is just mark the important number on the number line. So for those examples up here, that would just be 3. You don't have to like label every number, you know, from -10 to +10 or anything like that. Just whatever number is in that problem, you put it on the number line. And then if you have the or equal to line underneath your inequality symbol, then you're going to put a solid dot there. And then otherwise you're going to put an open circle there. Okay, so if it's a strict inequality, like x is strictly less than 3, you're putting an open circle. Alrighty. Then, let's see, so if it's less than, x is less than 3, so that means you want to shade all of the values that are less than 3, so that's everything to the left. And as long as you have the x on the left side of the inequality, then the arrow of the shading is going to be pointing the same direction as the inequality symbol. All right, and then, so less than, it's to the left, greater than, it's to the right. And then your interval notation is written in the same, like from left to right, smaller to larger, from left to right. So think of that arrow pointing to the left, it's pointing towards negative infinity. So it's everything from negative infinity up to 3, not including 3. So the parentheses next to the 3 in the interval notation shows that 3 is not included, just like the open circle. And then for x is greater than or equal to 3, so going from left to right, so that's 3 to infinity. And the bracket next to the 3 is showing that 3 is included in that solution set, just like the solid circle. Okay, so number 1, x is less than 1, so I'm going to mark 1 on my number line. And then it's strictly less than, not equal to, so I'm going to put an open circle there. And then it's less than, so I'm going to shade to the left. So it's it's great if you have like a highlighter, you could use that. Or if not, you can just shade it with a pencil, or you can kind of do like a zigzag shading like that. And then for the interval notation, it'll be parentheses, negative infinity, comma, 1, parentheses. Okay, number 2, so x is less than or equal to -2, so I'm going to label -2 on the number line. And it is less than or equal to, so that means I'm going to use a solid circle there. And then less than means I'm going to shade it to the left. And then my interval notation would be parentheses, negative infinity, comma, -2, bracket. And then number 3, x is greater than negative 3.5. So I'm just going to label negative 3.5 on my number line. It is strictly greater than, not greater than or equal to. So it's going to be an open circle. And greater than means I'm going to shade it to the right. My interval notation would be parentheses, negative 3.5, comma, infinity. All right, any questions about that? Okay, so then we're going to look at solving linear inequalities. So it's basically the same thing as solving linear equations, which we've done multiple times. There's just one additional rule that you have to remember with an inequality, which is if you multiply or divide by a negative number, you flip the inequality. So it'll change from less than to greater than or vice versa if you multiply or divide by a negative number. All right, so other than that, you just treat that greater or less than symbol just like an equality, like an equal sign. So on number 4, I'm going to add 5 to both sides, which gives me x is less than 8. And then I just mark 8 on the number line, and it's strictly less than, not less than or equal to, so I'm just going to use an open circle, and then less than means I'm going to shade it to the left. And my interval notation will be negative infinity, comma, 8 in parentheses. Number 5, I'm going to divide both sides by 6, which gives me x is greater than or equal to negative 7. All right, and since it's or equal to, I'm going to use a solid circle there. And greater than means I'm going to shade it to the right. My interval notation would be bracket negative 7, comma, infinity, parentheses. So wherever you have the or equal to, the little line underneath the symbol, that's where you're going to use a solid circle on the number line and a bracket in the interval notation. All right, number 6, we're going to divide both sides by negative 7. So since we're dividing by a negative, that means I'm going to flip that inequality symbol. So instead of a less than, it's going to be a greater than. So x is greater than negative 4. So I'm going to mark negative 4 on the number line. And it's strictly greater than as opposed to greater than or equal to. So I'm going to use an open circle, and then for greater than, I'm going to shade that to the right. And then my interval notation would be parentheses, negative 4, comma, infinity with parentheses. Number 7, I would multiply both sides by 3. So that would make that x is less than or equal to 6. Mark 6 on the number line. It's or equal to, so I'm going to use a solid circle there. And then for less than, I'm going to shade it to the left. And then it's going to be parentheses, negative infinity, comma, 6, with a bracket next to the 6. All right, on number 8, I have x's on both sides. So just like with an equation, I would want to get all the x's to one side, and preferably the left side, especially since it's an inequality. So I'm going to add 6x to both sides. That gives me negative 6 plus 2x is less than 1. And then add 6 to both sides. 2x is less than 7. And then divide both sides by 2. So x is less than 7 over 2. And if you wanted to change that to 3.5 or 3.5, I mean, we usually don't use mixed numbers, but if you need to, you can change that to a mixed number or a decimal. But I don't really need to. I'm just going to put it on here like this. All right, so it's going to be an open circle since it doesn't have the or equal to part. And then less than means I'm going to shade it to the left. And then for my interval notation, it's going to be negative infinity, comma, 7 halves, parentheses. Okay, and then compound inequalities, it's going to be, it basically has 2 inequality symbols in it because it's, and it's got like 3 sections. So something is less than something, which is less than something else. So we're trying to get x by itself. X is going to be in the middle section. So, normally I would say let's do whatever to both sides, but in this case, there's 3 sides or 3 sections or parts or whatever you want to call them. So I need to get x by itself, which means I need to subtract the 3. So I need to subtract 3 from each of the 3 sections, like that. Which gives me 3 is less than x, which is less than 5. So then on my number line, I'm going to mark 3 and 5. And neither one of them have the or equal to, so it's just going to be open circles. And so this is saying that x is between 3 and 5. So so I'm going to shade the middle part right there. And then for my interval notation, it's parentheses 3, comma 5. All right, on number 10, I'm going to add 1 to each of the 3 parts. So negative 10 is less than 2x, which is less than or equal to negative 4. And then I just need to divide each section by 2. So that would be negative 5 is less than x, which is less than or equal to negative 2. So on my number line, I'm going to mark negative 5 and negative 2. And then negative 5 is going to have an open circle. Negative 2 is going to have a solid circle. And then I'm just going to shade the middle. My interval notation would be parentheses, negative 5, comma, negative 2, bracket. On number 11, I need to add 5 to each of the 3 sections. So that gives me 2 is less than or equal to 2/3 x, which is less than 4. So to get rid of 2/3, I could say I'm going to divide by 2/3, which is also the same thing as multiplying by 3/2. So multiply each of those 3 sections by 3/2. So 2 cancels out. So that's just 3 is less than or equal to x, which is less than. 2 goes into 4 2 times, and 2 times 3 is 6. So 3 is less than or equal to x, which is less than 6. All right, so I'm going to mark 3 and 6 on my number line. And 3 is going to have a solid circle, and 6 is going to have an open circle. And then shade the middle. And then for my interval notation, it would be bracket 3, 6, parentheses. All right, on number 12, the first thing I need to do is multiply both sides by 2. So that 2 cancels out. So it's y plus 5 is greater than or equal to 8. And then just subtract 5 from both sides, which gives me y is greater than or equal to 3. So just mark the 3 on the number line. It's going to have a solid circle. Shade it to the right. And then for the interval notation, it's bracket 3, infinity, parentheses. All right, on number 13, the first thing I need to do is multiply by -2. So I'm multiplying by a negative, which is going to flip the inequality symbols. So that's going to be 2 is greater than a minus 5, which is greater than or equal to -12. So we always want to have it going from smaller to larger as it goes from left to right. So at some point, we're going to need to take that whole thing and just like flip it all the way around. We could go ahead and do that now. So the -12 is less than or equal to a minus 5, which is less than 2. So then we can just add 5 to each of the 3 sections, which gives us -7 is less than or equal to A, which is less than 7. So then on the number line, we're just going to label -7 and +7. And you just always want to make sure that you do have your numbers in the correct order, like the smaller one is on the left, the larger one is on the right. All right, so -7 is going to have a solid circle, and +7 is going to have an open circle, and then shade the middle. And then for your interval notation, it would be bracket -7, comma 7, parentheses. Okay. So next we're going to look at some inequalities using the word or. So the ones that we were doing before, those compound inequalities are kind of like and, like -7 is less than or equal to A, and A is less than 7. So, but we just combined it into one. With these, with the or, we basically just have 2 totally separate inequalities, and we're just going to graph them on the same number line. So, all right, so subtract 2 from both sides and get x is less than 1. And then on the other one, divide both sides by 2 and get x is greater than or equal to 5. So we have x is less than 1 or x is greater than or equal to 5. So we're just going to put those together in one number line. Again, just make sure that you have the smaller number on the left, the bigger number on the right when you put them on the number line. That's the really only important thing for as far as where the numbers are. So you have 1, that's going to have an open circle, and then it's less than, so you're going to shade to the left. Then we're going to have the 5 on the number line. That's going to have a solid circle, and we're going to shade it to the right. And then we can do our interval notation. So parentheses, -infinity, comma 1, parentheses. And then for where we have the or, we're going to have the union symbol, which looks like a big U. And we'll talk a little bit more about that in the next section. Then we're going to have bracket 5, comma infinity, parentheses. All right. Number 15, I'm going to distribute the 2, so that's going to be 2x minus 2 is less than or equal to 5. And then I'm going to add 2 to both sides. So 2x is less than or equal to 7. And then divide both sides by 2. So x is less than or equal to 7 over 2. And then divide both sides by -5. So x is less than -3. So we have x is less than or equal to 7 over 2, or x is less than -3. So we can put 7 over 2 and -3. 7 over 2 is going to have a solid circle. And it's less than, so we'd shade it to the left. And then -3 would have an open circle, and you would shade it to the left. So really, the first one already covered everything. The second one really didn't add anything to it. So for our interval notation, we can just say -infinity, comma, 7/2 with a bracket. The other one's already contained in there. All right, number 16, let's add 5 to both sides. That's going to give us x is greater than -7. And then let's subtract 2 from both sides. -x is greater than 8. And we would need to divide both sides by -1. So x is less than -8. So we have x is greater than -7 or x is less than -8. Again, let's make sure that we put these in the right order. -8 is smaller than -7. So -8 is to the left of where -7 is. They're both going to have open circles. Okay, so x is greater than -7. So from -7, we're shading to the right. X is less than -8, so from -8, we're shading to the left. So our interval notation is parentheses, -infinity to -8, close the parentheses, union, open parentheses, -7, comma, infinity. All right, here's some applications for inequalities. So number 17 says the cost to produce X DVD players is C equals 60X plus 600, while the revenue is R equals 85X. Find all intervals where they will at least break even. All right, so if they at least break even, that means the profit is greater than or equal to 0. All right, well, the profit is equal to the revenue minus the cost. So revenue is the amount of money they receive, cost is the amount of money they pay out. So profit is revenue minus cost. So revenue minus cost should be greater than or equal to 0. So that means 85x minus parentheses 60x plus 600 should be greater than or equal to 0. So let's distribute the negative. So I have 85x minus 60x minus 600 is greater than or equal to 0. Combine the like terms, 85x minus 60x is 25x. So 25x minus 600 is greater than or equal to 0. And then let's add 600 to both sides. So that would give you 25x is greater than or equal to 600. And then divide both sides by 25. So x is greater than or equal to 24. So it's asking for an interval. So it's going to be bracket 24 to infinity. So it means they need to produce and sell at least 24 DVD players to make a profit. All right. Number 18 says Martin has grades of 81 and 83 on his first 2 history tests. If he wants to maintain at least a B average in the class, what grade must he achieve on his 3rd test? Okay, so his average for the class after he takes the 3rd test would be 81 plus 83 plus whatever his 3rd test grade is, so we can use X for that since it's unknown, all divided by 3. 3 test grades, divided by 3. And if we want that to be at least a B average, we want that to be greater than or equal to 80. So then we can just multiply both sides times 3. So that 3 cancels out. So I have 81 plus 83 plus X is greater than or equal to. So 80 times 3 would be 240. And let's go ahead and combine the like terms. So 81 plus 83 is 164. So 164 plus X is greater than or equal to 240. And then let's subtract 164 from both sides. So X is greater than or equal to, so that would be 76. So he needs to get at least a 76 on the 3rd test for a B average. All right, let me see here. There's another section we're supposed to cover. There it is. All right. Section OA.1 is about set theory. Okay, so a set is a collection of distinct or different things. Those things are called elements. So here's a couple examples of some small sets. So set A has the elements 1, 3, and 10, and set B has the elements N, X, 0, 10, and 23. There's also such a thing as the empty set, which is a set that does not have any elements. All right. And so that can be represented by like a 0 with a slash through it, or by a set of those curly braces that don't have anything in between them. So the union of two sets is when you take, so the union of A and B would be you take all the elements of A and all the elements of B and lump them all together into one big set. Okay? Like a union, kind of like when two people get married and she brings all her junk and he brings all his junk, and then it's a one big pile of junk, right? So union is also often associated with the word or, like we just saw in the last section. So if something is in A or B, then it's in the union. And then the intersection is, so the symbol for union, it looks like a U, so that's pretty obvious. Then you have intersection, and the symbol for that is just the same symbol, but it's upside down, but it kind of looks like an N, so like N for intersection. And that is the overlap of two sets, so whatever they have in common. So that example, the only two elements that those two sets have in common is 10. So that's the only element that's in the intersection. The union has all of those elements though, and you only list each thing once. So even though they both have 10, you still only list it once when you're doing the union. So a good visual representation of these things is using a Venn diagram. So like the red circle represents set A and the blue circle represents set B. And so where they overlap and make purple, that's the intersection. So that purple area is the intersection of A and B. Whereas the whole entire shaded area is the union. Okay. All right. Okay. So if we want to find the union and intersection of these sets, I like to do my Venn diagram first. I always like to start with the intersection. So what do those two sets have in common? Well, they both have 1 and 5. So my Venn diagram, I would put 1 and 5 in the middle like that. I could go ahead and write that down. So the intersection, and you need to use the curly braces to show that it is a set containing those elements 1 and 5. So then the other elements of A would be -7 and -3, and the other elements of B are 9 and 13. So that's how your Venn diagram looks. And then let's just list them all out. And I usually like to try to list them from smallest to largest, although it's not required, but it seems to just help stay more organized and everything. So the union contains -7, -3, 1, 5, 9, and 13. And then the intersection just contains 1 and 5. All right, any questions about that? All right, number 2. So what elements would be in the intersection of A and B? Nothing. So the intersection is equal to the empty set. So when I fill out my Venn diagram, I'm just going to put all the elements of A over here, A, E, I, O, U, and all the elements of B over here, C, D, F, G. Okay, so that's how the Venn diagram would look. And normally I might try to put these in alphabetical order, but I don't really feel like it right this minute. So I'm just going to list all the elements of A and then list all the elements of B. So A, E, I, O, U, and then C, D, F, G. All right, so A, we have 0, 2, 4, 6, 8, 10, 12, 14. And B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I always like to start with the intersection because it's smaller. So what elements would be in the intersection? Anybody want to say? 12. What else? So how about, let's start at 2. And then that dot, dot, dot means everything in between there. So 4 and 6 and 8 and 10 and 12 are all the intersection. And then for the union, okay, we would have, I'm going to try to do these in order so I don't get confused. 0 and 1 and 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, basically. And 14. Okay. So all of the whole numbers from 0 to 12 plus 14. All right. And then what is A intersection with the empty set? So what does A have in common with the empty set? Well, nothing, because there's nothing in the empty set. So anything intersected with the empty set equals the empty set. It's kind of like multiplying by 0. Anything multiplied by 0 is 0. All right. What about B union with the empty set? So in that case, it's like with the union, you still have to include everything from B plus throw in everything from the empty set, which is nothing. So it's kind of like adding 0. So anything union with the empty set is just itself. Okay. So next we're going to apply the unions and intersections to intervals because intervals are a type of sets. All right. So we just talked about intervals in the last section, but for example, negative infinity to 3 with parentheses is a set of all real numbers that are less than 3. Okay, from, with 0 to 10 with brackets, that represents the set of all real numbers that are between 0 and 10, including 0 and 10 themselves. And from negative 2.5 to infinity with a bracket next to the 2.5, so that would be the set of all real numbers that are greater than or equal to negative 2.5. Okay, so fine. Okay, so number 4, we want to do the intersection of those two sets. And I'm going to use a number line to try to help figure it out. So we have 5, open circle, and we would shade to the left. And on the other one, we have 5 with an open circle, and we would shade it to the right. And we're trying to find the intersection or the overlap of these two. So where do these two sets overlap? Well, technically they don't overlap at all. Some people might say 5, but actually 5 is not an element of either of those sets because neither one of them actually include 5. That's what the parentheses are telling us. So the intersection of those two sets is the empty set. They have no elements in common. They have no overlap. All right, on number 5, it's basically the same thing, only with brackets. So the number line, it would look pretty much the same, only we would fill in those circles. So in that case, they do overlap only on the number 5. So the intersection for those two sets would be just not an actual interval, but just the set containing the number 5. And then on number 6, that's basically the same thing, only difference is they're asking us for the union of those two sets. So the union is basically all of them together. So if you put those two together, like on the same number line, you would just be covering the whole entire number line from negative infinity to infinity. So the union of those is negative infinity to infinity, all real numbers. All right. So negative infinity to negative 2 with parentheses is like that. And then negative 8 is smaller than negative 2, so it would be over here somewhere. Also with the open circle, and then, but we would shade everything to the right for that one. So they're looking for the intersection, so where they overlap. So the part where they overlap is here, from negative 8 to negative 2. Number 8, we have, okay, negative 10 to negative 3, the open circles, shade the middle of that. And then negative 7 is in between those two, and negative 2 would be over here because it's bigger. And then it's asking for the union. So the union is everything covered by both of those. So the union would be going from negative 10 all the way to negative 2. All right, and on number 9, I want to change that 4 to a negative 4, actually. So negative 10 to -3. And then -7 to -4. So that's why I wanted to change that to a -4, so we could have an example like this where that second one is all the way inside of the first one. So if we wanted to do the union in this case, it would really just be this larger set because it already takes in the whole second set. So in this case, the union would just be -10 to -3. All right, and then let's change that to a -4 on number 10 as well. So then it's basically the exact same thing, only it's asking about the intersection. So the intersection where they overlap is basically just going to be equal to that smaller set. So it's just that smaller set. -7 to -4. Alrighty. So that's the end of today's lesson. Make sure that y'all are doing your homework. And I will see y'all next week.